Bismillahirrahmanirrahim. Hello, dear students. I hope you are all fine. I welcome you all to the class of real analysis. In today's lecture, we are going to discuss some important basic concepts. Actually, these concepts are the base of the incoming lecture. So, in this short lecture, we will discuss the largest element of a set versus the supremum of a set, and the similar manner we can define smallest element of a set versus to infimum of a set. The concept of largest element and the supremum of a set are very similar that oftenly confuses students. So to elaborate uh, about largest element and supremum of a set, firstly we define what is the largest element of a set and the supremum of a set. So the largest element of a set can be treated as largest element of a set is simply the maximum element or the maximum value is the maximum element within a set within a set. So the largest element and sometimes also called the maximum element is simply the maximum value of the set within the set. Whereas the supreme of a set you can define as a least upper bound. Supremum you know that is called a least upper bound. A least upper bound that is greater than equal to every element of a set. Now, both definitions look like similar. Largest element is also the maximum value, and the supreme, that is actually the least upper bound, is an element that is greater than equal to every element. So, in the sense greater than equal, uh, this perceives that both definitions are the same. But the key difference between both definitions is only one. What is the key difference between both definition? Key difference. Key difference between both definition is that largest or the maximum element is always element of a set. It always belong to a set. But for the supremum of a set, it is not necessary that supremum always an element of that set. This is the key difference. Largest element is always an element of a set. Is always an element of a set. Whereas for supremum, it is not necessary that it is an element of set. An element of set. Now we elaborate both concepts by a simple example. Let us consider the set of first 20 natural numbers. In some cases, you will see that both largest element and the supremum have the same concept. They are both similar. They are both equal. But in some cases, you can find that both are different. So we elaborate these by examples. In first example, let us consider E is the set of first 20 natural numbers. Now you can observe that what is the largest value of this set? What is the largest value of this set? Here the largest value that is within the set E is 20. So the largest element, also called maximum element of E is equal to 20 because 20 is greater than equal to all other. Now, if I ask, what is the supremum of E? What is the supremum of E? You know that a supremum is the least upper bound. What is upper bound? In my previous lecture, I have discussed about an element. Suppose S is an order set and E is its subset. S is an order set and E is its set. Then an element beta belong to S is called upper bound of E if beta is greater than equal to every element of E where X is belong to set E. Then beta is called upper bound. Now if a set has an upper bound, then it may be possible that it has infinite many upper bounds. So the smallest one among all these upper bounds will be the least upper bound. So every element that is greater than equal to 20 in the set of real number R is upper bound of E. Every element or every real number greater than equal to 20 is an upper bound. UV means upper bound is an upper bound of E. But you can see that the smallest upper bound among all these is 20. So the least upper bound, that is the supremum of the set, actually is here 20. So supremum of E is equal to 20. So in this example, you can see that both the maximum and the largest element are same. Now I discuss a second example, which you will see that supremum of set and the largest element of set are different. Let us consider second example. Let E represent an open interval over the real line R. Let consider the interval 0 less than x, x less than 2, where x is a real number. Now, what is the largest element of this interval or this set? This interval shows all the real numbers that lies between 0 and 2. That lies between 0 and 2. All the real number that lies between 0 and 2. But neither 0 nor 2 is included in this set because this interval is an open interval. So 2 is not the largest element of this interval. 2 is not a largest element of open interval 0 to 2 because for the largest element the necessary condition is that largest element should be an element of the set. The maximum number, the largest number, can approach to 2 in this interval. The largest number you can pick here may be 1.99999, suppose, but this is not exactly equal to 2. This approaches to 2. So 2 is not the largest element of this interval because 2 does not belong to this set. But still, this interval has a supremum. What is the supremum of this interval? You know that every real number that is greater than equal to 2 is its supremum, is its upper bound. So the least upper bound, that is the supremum, is 2. So this set has a supremum equal to 2. Now you can see that supremum of the set interval exists, but the largest element not exists. So in this case, you can observe that supremum and the largest elements are different due to only one reason, that the largest element not belong to this set. Okay, let us suppose. Let us suppose at this time our interval is closed interval. Our interval is closed interval, that is 0 less than x less than equal to 2, x belong to 0 to 2, where x is the real number. Now, what is the largest element of this interval? Obviously, the largest element at this time is equal to 2. What is the supremum? Supremum of this set is also equal to 2. So what conclusion can be drawn from here? Whether every time whenever your interval is closed, your supremum and largest element have the same meaning. From these two examples, we can perceive that. The first example is example of open interval. That's why you can say that largest element is different from the open or supremum. And now when the your interval is closed interval, both largest and supremum are same. So any students can see that whenever our interval will be closed interval, then largest element and the supremum have the same meaning. Is this necessary always? So let us consider a fourth example. Suppose our x belong to the interval closed interval 0 to square root 2, where x is a rational number. Where x is a rational number. Now, what is the largest element of this? Whether the largest element exists, even our interval is closed interval. The largest value that maybe that you maybe choose here, largest element is not a square root 2. Even the interval is closed interval. Because there is an additional condition on this interval. This is a closed interval, but our x is a rational number. The right hand point of the interval is square root 2. Square root 2 not a rational number. This is a irrational number. So due to this additional condition, this set again has no largest element. Even square root 2 belong to this interval. But due to this condition that our x is a rational number, so square root 2 is not a rational number. That's why this set has a no largest element. Does not exist. Does not exist in which set? In Q, because x is a rational number. If I add the condition x is a real number, then what will be the largest number? Then you can say that because x is a real number, so the largest element is square root 2. Now, this is whether the supremum of this set exists in R. Yes, the supremum of this set is again a square root 2. So, this is not necessary that always a closed interval has a largest element as well as supremum. Sometimes additional conditions can matter. In the similar manner, we can understand the concept of the smallest element and the infimum. Both equal, uh, whether this set has an infimum and what is the smallest element of this interval. You know that here x is a real number and the infimum is the greatest lower bound. You know that every real number that is smaller than 0 is represent its lower bound. But the greatest lower bound represent its infimum. So the infimum of this set is 0. Whether its smallest number exists? No. Its smallest number does not exist because 0 does not belong to the interval 0 to 2. So the most important condition for the largest element and the smallest element is that they always belong to that set. I hope today's lecture was helpful for you. Inshallah, in the next lecture, we will discuss an important theorem from the book Mathematic Principle of Mathematical Analysis written by Walter Rudin, that this given set A, where A is x such that x belong to Q and x square is less than 2 as a no largest element. So, inshallah, we will meet in the next lecture. Okay, take care. Allah Hafiz.